You'd think, with all the incredible technology we have today, we'd have a handle on urban flooding. I mean, we throw everything at it. Super advanced computer models, satellite data, the whole works. And yet, something's not quite working. There's a hidden flaw in the system, a really surprising reason our best efforts are coming up short. So in this explainer, we're going to dig into what's really going on.
I mean, this is the big question, right? We have more data and more powerful tools than at any other point in history. But urban floods are still causing over $500 billion in damage every single year. And that number is only going up. So what gives? If the tech is getting smarter, why is the problem getting worse? Well, it turns out the answer isn't in the code. It's somewhere a lot more human.
And, before we dive into all the data and the models, it's so important to just pause and remember what's really at stake here. This quote is from the dedication of the very PhD thesis we're exploring. It just grounds the whole thing, doesn't it? It reminds us that this isn't some abstract technical problem. We're not just talking about maps and software. We're talking about real people, their homes, their communities, and a threat that is all too real.
Okay, so to figure out where things are going wrong, we first have to appreciate the tools that are supposed to be making things right. The way we fight floods today is all about data, an incredible amount of it. And it's all processed by two key scientific fields. Let's break them down.
So first up, you've got hydrology. The easiest way to think about this is that it's the science of water itself. It's the part of the equation that predicts the flood, where the water's going to come from, how fast it'll move, and just how high it's going to get. This is the engine of our whole predictive system.
Next, we have GIS, which stands for Geographic Information Systems. So, if hydrology is the engine that predicts the flood, GIS is the digital map where the flood actually happens. It understands the terrain, the streets, the buildings, all the physical stuff that tells the water where it can and can't go. Now, when you smash these two fields together, the predictive power of hydrology and the spatial awareness of GIS, you get something called HydroGIS, and it's an incredibly powerful combination. It allows city planners and engineers to model potential floods with amazing accuracy and, in theory, make much smarter decisions, or at least that's the idea.
So, if these HydroGIS tools are so powerful, why are we still in so much trouble? It's because the problem isn't the tool itself. The research we're looking at today suggests the real flaw is in how the tool gets built and used. There's a huge disconnect somewhere in the system.
To really get our heads around this, let's use a little analogy. Imagine building one of these complex flood models is like building a house. It's a massive project, right? It involves a whole team of different people, and every single person on that team has a very specific and crucial job to do.
So let's meet the project team. First, you've got your technical experts, the hydrology and GIS modelers. Think of them as the architects and engineers, the ones who draw up the scientific blueprints. Then you have the HydroGIS modeler. This person is like the general contractor, responsible for bringing all those technical plans together. The client? Well, that's the city's decision makers who commissioned the project. And finally, you have the residents, the people who actually have to live in the city and deal with the results.
You can probably see where this is going. What happens if the architect doesn't talk to the engineer? Or if the contractor doesn't really understand what the client wants? And what if nobody even bothers to ask the people who will actually live there what they need? You don't get a dream home, you get a complete disaster. This research suggests that's exactly what's happening with our flood defenses.
And this is where things get really fascinating. The researcher behind this thesis didn't just have a hunch that communication was the problem. Nope, they set out to actually measure it. They decided to literally map the human factor.
They did this by looking at 32 different real-world HydroGIS projects. And for each one, they systematically measured the depth of communication, what the study calls integration, between all the key players on that house-building team we just talked about. And the results? Well, they're pretty startling.
So what did the data show? Well, first, the integration between the core technical experts, our architects and engineers, was found to be at 26%. This is actually the strongest link in the entire system, which kind of makes sense, right? They're the specialists, they're speaking the same language. But let's move one step out from there. The link between the general contractor, the HydroGIS modeler, and the client, or the city decision makers, well, that connection already drops down to 23%. And what about the communication between that client and the residents, the people who are actually going to be affected by these decisions? That link falls even further, all the way down to just 19%.
But the most shocking number of all reveals the weakest link in the whole chain. The integration between the general contractor and the scientific blueprint itself was a mere 12%. I mean, think about that. The person tasked with building the final integrated tool was the most disconnected from the core science.
When you look at it as a bar chart, you can really see these communication gaps. You see the connections steadily declining as you move from the purely technical experts out towards the public. But notice what's missing from this chart. That shocking 12% we just saw. That's because it represents a disconnect at the very heart of the project itself. A flaw so deep, it's not even about communication between teams, it's a crack in the foundation.
So here it is, the crucial point. The system is failing not because the code is bad or the data is wrong. It's failing because of these deep fractures in human communication. The person integrating the science is disconnected from the science. The decision makers are disconnected from the public. Our high-tech house is being built on a foundation of miscommunication.
So how do we fix this? Well, the great thing is, this research doesn't just diagnose the problem, it actually offers a cure. It lays out a practical framework for building better blueprints, not just for the software, but for the entire human system that creates and uses it.
And here's the framework. It's a clear 4-step process. First, get everyone, the tech experts, the city planners, the residents, everybody in the room from day one. Second, actively measure the communication between them, just like this study did, so you know exactly where the weak spots are. Third, focus your energy on systematically strengthening those weak links. And fourth, and this is the ultimate goal, build tools that are actually useful for everyone involved, not just some black box that only the experts can understand.
Ultimately, what this research shows is that effective flood management isn't just a technical challenge, it's a communication challenge. Having the right conversations at the right time with the right people is just as important as having the right algorithm. This is how we build truly safer, more resilient cities.
And that leaves us with a final thought. This framework was designed to fix our flood defenses, but just think about all the other complex systems that make a city work: transportation, public health, the energy grid. Where else are we building these powerful, amazing tools without having the crucial conversations needed to make them truly work for everyone?